So I am recording this. If you see that I make a mistake, please stop me so I don't upload a mistake. On quizzes on Wayground, I want to have a couple of questions on the assignment where I ask you to graph this exponential. Is this a growth or a decay function? Growth, because base is greater than 1. And how do we do this? All you got to do is graph the asymptote and plot 2 points, and the rest gets done for you. So you're going to take this asymptote right here, and you're going to move it up or down depending on where you need to place it. And of course, the asymptote comes from the k value. In this case, the k value is -1, okay? So you already know that your asymptote is y equals k. In this case, y equals -1. So all you got to do is move that asymptote to -1. And then from there, you need to find a couple more points. So you could go to an XY table and you could plug in some pretty easy numbers. Like if you wanted the x-intercept, all you have to do is plug in 0 for x, okay? I'm sorry, the y-intercept. I keep saying x-intercept. If you want the y-intercept, if you want to know where it crosses the y-axis, all you have to do is plug in a 0 for x. So you plug in a 0 right there, and 2 to the 0 is 1, and 1 times 3 is 3, and 3 minus 1 is 2. So we now know that it has a point at 0, 2. So on quizzes, you're going to have 2 dots on your graph. You drag one of those dots to 0, 2, and put it right there. And you need another dot, so you could try plugging in a 1. When you plug in a 1, 2 to the 1 is 2. 2 times 3 is 6. 6 minus 1 is 5. So when you plug in a 1, you get out of 5. So you simply go to 1 and 5, and you'll be right there. Bless you. And just with those 2 dots, Wayground will graph this right here. And that is your exponential growth function with the growth factor of 2. Got it? So it's a lot easier than graphing by hand because it actually does it perfectly for you. Let's take a look at another. By the way, every one of these is on the assignment that we're doing today. So on this guy, I'm going to start by moving the asymptote where? +5. So you're at 0, 1, 2, 3, 4, 5. Put it there. Now we need some more points. So let's go for XY table. And what should we plug in? 0. Always looks good to find the y-intercept. When you plug in 0 right there, 4 to the 0, anything to the 0 is 1, but you have a negative in front. So that's a -1 plus 5. That is 4. So you plot the point 0, 4, 0 on the x, 4 on the y. It's down there below the asymptote. And that makes sense because the a value is negative, which means that your entire graph has to be below the asymptote. Okay. Now we need another point. What other point should I plug in? 1? Sure, that sounds great. Okay. Plug in a 1 right there. 4 to the 1 is 4. With the negative in the front, so -4. -4 plus 5 is 1. So when you plug in a 1, you get out of 1. 1, 1, put a dot right there. And just with those 2 dots, quizzes will graph this growth function like that. With the asymptote and those 2 dots, you have the perfect growth function. Now, this is a growth function in a negative direction. Again, remember the distance grows from left to right. So it's a growth function in a negative direction. Here's another. Where do I move my asymptote to? -3. So we're going to take it. Well, that's not the way. I guess I could do that. Yeah, -3 right here. And then I need some more points. What should I plug in? 0 looks good. And we'll try other values right now, but let's go with 0 first. Plug in 0 right there. Anything to the 0 power is 1. 1 times -2 is -2. And -2 minus 3 is -5. So 0, -5. 0, -5 is right here. Let's put a dot right there at 0, -5. And then from there, we need another point. What other point should I use? Should I use 1 the way I did on the other ones? Well, if I do plug in a 1, 2 to the 1, I mean 1/2 to the 1 is 1/2. And I end up with the fraction, but that does work out beautifully because this a value is a -2. So maybe I need to show some work right here. You have -2 times 1/2 to the 1 power, and then -3 at the end. So this is just 1/2, and -2 times 1/2 is -1, and -1 minus 3 is -4. So when you plug in a 1, you get out a -4. So let's go to the coordinate 1, -4, and you'll get that dot right there. And just with those two red dots and the asymptote that you move to -3, you will have the decay function that looks like that. And this way it just shoots off in that direction. So on quizzes on Wayground, it's super easy to graph these, okay? Let's do one more. The asymptote goes where? -4. And from there, I need some coordinates. I need 2 points. So what do I plug in? 0. Anything to the 0 power is 1. 1 times -3 is -3. -3 minus 4 is -7. So if you go to 0, -7, you're right there. And then from that point, let's plug in another value, like in this case, 1 would work out beautifully as well. Because when you plug in 1 right there, it stays 1/3. And -3 times 1/3, if you think about that, -3 times 1/3 minus 4. Well, that cancels out. You end up with a -1 minus 4, which is -5. So when you plug in a 1, you get out a -5. So you go to 1 and -5. That would be right there. And just with those two dots, with your asymptote right there, you'll have your exponential decay function. Let's try one more. Here we go. Move that asymptote where? 5. Oh, I can't move it. What's going on? It's stuck. Oh, there it is. 5. Okay. And then I need 2 more points. Everybody should know by now, plugging in 0 works out pretty good. Plug in a 0 right there, that becomes 1. 1 times 4 is 4. 4 plus 5 is 9. So plug in a 0, get out a 9. 0, 9 is right there. And you can plug in a 1. 1's been working out great so far. Plug in a 1, it stays 1/4. 4 times 1/4 cancels out, you get a 1. And 1 plus 5 is 6. So 0, 9 and 1, 6. With those two dots, you will have your decay function on quizzes, like so. Okay, this next one has to be the last one. Asymptote is at 7. Make an XY table. Plug in an easy number like 0. When you plug in 0, you get a 1, because anything to the 0 power is 1. With the negative in the front, it's a -1, and -1 plus 7 is 6. So 0, 6, 0 on the X, 6 on the Y. You have that dot. Plug in another number. What other number should I plug in? Anybody? Well, if I plug in a 2, think about that. I'll have -1/2 to the 2nd power plus 7. But when you do this on a calculator, 1/2 to the 2nd power, you get 1/4. So you have -1/4 plus 7, and you get 6 and 3/4. And you can't really go 2 and 6 and 3/4. You can't go 3/4 of the way up on the Wayground. So it only goes by full units. So this did not help us. Okay, so we got to think a little bit more on this one. How could I get this fraction to become a regular, a non-fraction, like a regular number, right? An integer. How could I get this to become an integer? Well, I'd have to plug in what? Anybody? -1. That's right. Plug in a -1, And that would cause this to flip. If you guys remember negative exponents, the negative exponent causes it to move to the other side. So if you have 1 to the negative 1, it goes down, 2 to the negative 1, it goes up. So 2 didn't work, but we are going to plug in a negative 1. That's the better option, okay? So when you do plug in a negative 1, you're going to have negative 1/2 to the, plugging in a negative 1 power, and then plus 7. So what this does, the 1/2 to the negative 1, if you did 1/2 to the negative 1 on the calculator, that would actually equal to 2. So what you really have is the negative sign in front with a 2, and then the plus 7, and that actually gives you a 5. So when you plug in a negative 1, you get out a positive 5. I hope that makes sense, okay? So if we go to negative 1 and positive 5, negative 1, positive 5, you're right here at that dot. And when you have those two dots, the computer will do the rest. Oh, that's ugly. And there's your exponential decay function from left to right. Okay, so I'm pretty sure that was the last one, and none of these had the h value, like a minus h. So let's do a couple of those because Whiteboard did not let me do those. I don't know why it doesn't let me type in a minus h up here. So let's say we had this equation, y equals 8 times 1/2 to the x minus 1 plus 3. It's obviously a decay function. And we want to graph this on a 10 by 10 graph. And it says which inputs would be good to select. And you could pick all that apply, okay? So do you guys think 1 would be, or 0 would be a good option in this case? Bless you. If you think about this, if you plug in a 0, well, plugging in a 0 right here, 0 minus 1 is negative 1. And that's a power of negative 1. So you have 1/2 to the negative 1. That would flip it, and it would become 2. And 2 times 8 is 16, and 16 plus 3 is 19. That's off a 10 by 10 graph. So I would definitely not pick 0. Okay, what about 1? If I plug in 1, will that give me a coordinate on a 10 by 10 graph? Well, think about that. Plugging in a 1 right there. 1 minus 1 is 0. Anything to the 0 power is 1. 8 times 1 is 8. 8 plus 3 is 11. So when you plug in a 1, you get out an 11. That's also off a 10 by 10 graph. So you're not going to pick 1 either, right? What about the number 2? Well, if you plug in the number 2, will we get a coordinate on a 10 by 10 graph? Plugging in a 2 right there. 2 take away 1 is 1. 1/2 to the 1 power is 1/2. 1/2 times 8 is 4. And 4 plus 3 is 7. So plugging in the number 2 is a good option because it gives you a coordinate on the XY plane of a 10 by 10 graph. Does that make sense? Okay. How about 3 though? Will 3 also work? Maybe it's just the number 2, maybe it's 3. You could pick all that apply on this question on Whiteboard. So let's try 3. When you plug in a 3 up here, 3 minus 1 is 2. So you would have 8 times 1/2. 3 minus 1 is 2, and then plus 3. So when you do this, 1/2 to the 2 power, to the power of 2, that becomes 1/4, but you're still multiplying by 8, and then you're adding 3 at the very end. And if you go 8 times 1/4, that's really a 2, and 2 plus 3 is really 5. So when you plug in a 3, you get out of 5. So yes, that's also a good option. So you have the input of 2 and the input of 3 are great options because they do give you 2 points, and then plus your asymptote, you'd be able to graph it. Okay. Let's do a couple more of these just to practice when we actually have an h value up here, x minus h. Here's another exponential growth function because the base is 2. And it's asking us that we want to graph it on a 10 by 10 graph. Which inputs are good to use? Check all that apply, pick all that apply. Maybe all of them work, maybe none of them work, right? So let's try plugging in 0. And when we plug in 0 into here, 0 minus 3 is minus 3. And what is 2 to the negative third power? Anybody? 2 to the negative third power? You could use a calculator, and that'll be 1 over 8. It'll be 1/8, right? Let me actually show my work here. So you have 8 times 2 to the 0 minus 3 power minus 4. So that's really 8 times 2 to the negative 3 power minus 4. And this 2 to the negative 3, you move it to the other side, and the 8 stays on top, and on the bottom you now have 2 to the positive 3. And this is one way of doing it. And then you have a minus 4 at the very end. And what is 2 to the positive 3? It's 8. So you have 8 divided by 8, which is 1. And 1 minus 4 is negative 3. So by us plugging in 0, you get out a negative 3. So that is definitely a good option. That's a point on the 10 by 10 graph. Could we plug in a 1? Well, you'd have to do that. Plug in a 1 right there. 1 minus 3 is negative 2. What's 2 to the negative 2 power? Anybody? 2 to the negative 2 power? It's 1/4. No? Nobody? Okay. Let me show my work here. Let me erase this. Let me now show my work of plugging in a 1. So we have 8 times the base 2, 1 minus 3, and then minus 4. So you really have 2 to the negative 2 power with the 8 in the front. Now that 2 to the negative 2 power has to go underneath, and it becomes positive 2 to the positive 2 power. So it's no longer up on top, and you have a minus 4 at the end. So you really have 8 divided by 2 squared, which is 4. So you really have 8 divided by 4. 8 divided by 4 is 2, and 2 minus 4 is negative 2. So when you plug in a 1, you get out a negative 2, and that also works. Okay? And then you keep going. You would now try plugging in a 2. Of course, you could do all this work on a calculator. Plugging in a 2, you got 8, 2. Let's plug in a 2 now to see if it works. That's 2 minus 3, and then minus 4. Well, 2 minus 3 is a minus 1. So you really have 2 to the minus 1 power. 2 to the minus 1 power, but times 8 in the front and a minus 4 at the end. So 2 to the minus 1 goes down. It becomes 2 to the positive 1. It's no longer up on top. So you really have 8 divided by 2, which is 4, and then take away 4. 4 take away 4, whoa. 4 take away 4 is 0. So when you plug in a 2, you get out a 0. And that also lands on a 10 by 10 graph, so you'd pick that one as well. Try plugging in a 3. The 3 is probably the easiest one to plug in because 3 minus 3 is 0. Anything to the 0 power is 1. 8 times 1 is 8. And 8 take away 4 is 4. So plugging in a 3 gives you out a 4. So technically, every single one of these inputs would work on a 10 by 10 graph. You'd be able to get coordinates on a 10 by 10 graph. Let's do one more, and then we'll be done. How about this guy? So only the 3 works in this case. Let me explain. If you were to try to do an XY table and you actually tried 0, well, plugging in 0, 0 will give you a negative 3. 0 minus 3 is negative 3. And remember, a negative power is going to cause this to flip. So the negative 3 is going to make that a 2 to the third power, which would be 8. And 8 times 8, 64, minus 5, you're way off a 10 by 10 graph. Okay? I mean, it's a point. It actually exists, but it's not good if you're graphing on a 10 by 10 graph. Likewise, if you tried the number 1 right there, 1 minus 3, let me show my work so you're not confused. If you plug in a 1, it's also not going to work because 1 minus 3 is negative 2. So you're going to have 8 times half to the negative 2 power minus 5. And this negative 2 causes this to flip. So you really have 8 times 2 to the positive 2, and then minus 5. And right here, 2 squared is 4. 8 times 4 is 32. 32 minus 5 is off the graph, right? So you're talking about like 127 that's off the graph. So you're not going to pick that one either, okay? And if you go through these, the only one that actually works that'll land on a 10 by 10 graph is the third option, 3. So if you did, let me get this out of the way. Let me show my work here. Y equals 8 to the 1/2 power. Plug in that 3. You have -3 minus 5. Obviously, this becomes 0. Anything to the 0 power is 1, and 8 minus 5 is 3. So when I plug in a 3, I get out a 3. And that's the only one that actually lands on a 10 by 10 graph. 2 doesn't work, right? No? Should I show that it doesn't work? Sure. Why not? Let's see, let's try 2. Y, so I'm going to input 2. I'm going to show that it doesn't work. Y equals 8 times 1/2. And I'm inputting the 2 minus 3, then minus 5. That's really 8 times 1/2 to the -1 power minus 5. And that -1 power is going to flip that, and it'll be a 8 times 2 minus 5. And that'd be a 16 minus 5. That is 11. So when you plug in a 2, you get out an 11. That's an actual point, but I want points that are on a 10 by 10 graph. So this would not be on there either. It's only the input of 3 that would give you a coordinate that's on a 10 by 10 graph. I hope you understand that. This video will be uploaded to Google Classroom, and we do have an assignment right now that will have these questions on there.